is about forces. In chapter 4, we have two learning outcomes. 4.1 Basic of Forces and Free Body Diagram. 4.2 Newton's Law of Motion. Okay, in 4.1, we need to identify the forces acting on a body in different situations. B. Sketch free body diagram. And C. Determine static and kinetic friction. What do you know about forces? Force is something that is capable of changing an object's state and motion. Force is a vector quantity. SI unit for force is newtons or kg meter per second square. Type of forces. First, we have weight. Every object that has mass will experience weight. Second, tension. Every tied object by a rope or cord will experience tension. Normal force. Any object in contact with the surface will experience normal force. Friction. Object on rough surface will experience friction. And the last is external force. Object is be pushed or be pulled is called external force. Okay, look at definition for weight. Weight is the force of gravity pulling you down. Okay, look at the picture. Okay, the man has a mass 90 kilogram and it feels weight downward. Okay. Weight is equal mg, where m is mass in kilogram. G is gravitational force. Okay, where is slightly with altitude because weight depends on the strength of the gravitational field. In Earth, the value of G is 9.81 meter per second square. Weight acts perpendicularly downward on the surface. Weight is an action on the surface. Weight of a body can be represented by a force arrow that points vertically downward from the center of mass. Okay, example, look at the picture. Okay, weight always downward. Okay, value of weight for the 1 kilogram mass bag is 9.81 Newton. Okay, look at first case in horizontal surface. Weight downward. Incline plane. weight always directed downward. Hanging object, weight also downward. Second, tension. Definition for tension is force on a stretched material. The pulling force that is directed away from the object and attempt to stretch or elongate the object. Example, the man pulled the trolley with a rope. So the rope will experience tension. Case 1, horizontal surface. The man pulled the box with a rope. The rope experience tension. The direction of tension away from the object. Case 2, pulley. So we have tension 1 from the object A, and we have tension away from the object B. Normal force. The definition for normal force is the force exists whenever two solid materials are in contact at perpendicular to the surface. So normal force is perpendicular to the surface. The existence of normal force the object on the horizontal surface. First, it have weight because the object have a mass, and the object in contact with surface, so it has normal force. The fourth one is friction force. Friction force is a retarding force that resists motion on the surface. Friction force always acts parallel to the surface in contact and in the opposite direction of the motion. Look at the picture. The man pushed the cardboard and the cardboard will moving. So in the surface, it has friction force. Friction between solids is generally classified into two types. First, static friction, and the second one is kinetic friction. Static friction. Static friction is the friction force exists between two objects when there is no motion or the object begin to move. We have a friction retarding the motion. Okay. The object on an inclined plane is at rest. So the object has a static friction. Okay, may have different value up to some maximum. Okay, frictions is equal or less mu s n. Okay, just before an object starts to slide, Fs is maximum. So the formula of static friction force is equal mu s n. Mu s is coefficient of static frictional force, and n is a normal force. N is the normal force. Kinetic friction. Okay, kinetic friction force exists between two objects when there is relative motion of the interface of the surface in contact. Alright, picture the ice skating. So it has a motion and it has kinetic friction. Okay, case 1, horizontal surface. Okay, the block have a external force F and the ball is accelerate to the right. So the ball will experience kinetic frictional force. Okay, inclined plane. Okay, also have external force F. The ball will accelerate and the ball will feel kinetic frictional force. Okay. Okay, the object have kinetic frictional force. Kinetic frictional force acts in the direction opposite to the motion of and has a magnitude of Fk sama dengan mu Kn. Why static friction is greater than kinetic friction? Okay. Because there are more force at work keeping an object stationary than there are force working to resist the object once it is in motion. Okay, so value of mu s and mu k depends on the nature of the surface in contact. Okay, normally mu coefficient of friction less than 1. So in general, mu s is greater than mu k. Okay, the last one, external force. Okay, we have external force, pull, force that act on an object to draw toward oneself of itself. Okay, pull. the door. Pull the trolley. Push. To exert force upon or against an object in order to move it away. Push the door. Push the car. Okay. For a force to accelerate an object, it must come from outside it, either pull or push. Lesson 2. Sketch free body diagram. Free body diagram is defined as a diagram showing the chosen body by itself, with vectors drawn to show the magnitude and direction of all the forces applied to the body by the other's body that interact with it. To construct free body diagram, it is extremely important to know the various types of forces. Case 1. Horizontal surface. Okay, object lies at rest on a horizontal surface. To start, draw a free body diagram. You need to draw a dot to represent the object of interest. Okay. Second, draw properly the forces vector with arrow. Okay, let's say we have normal force upward and weight directed downward. All the forces drawn are outward from the dot. B. A ball is pulled along a rough horizontal surface by a horizontal force F. Okay, free body diagram. We have normal force perpendicular to the surface. We have weight always downward. We have external force and kinetic frictional force. Okay, the direction of acceleration, you can draw it. Case 2, incline plane. The ball is pulled along a rough inclined plane by a force F. So, it free body diagram. Okay, you can draw a dotted line to represent a x-axis for the inclined plane. Okay, start with one dot. We have normal force perpendicular to the plane. We have weight. We have external force and frictional force. Also, you need to show the direction of acceleration. Hanging object. Okay, free body diagram. We have tension directed away from the object, and we have weight. Okay, the other one. Okay, we have three forces acting on object M, which is weight, tension 1 and tension 2. Case for pulley. Okay, pulley, we have M1 and M2. This is the direction of acceleration. Okay, so we need to draw a free body diagram for M1. M1 have tension 1 and weight 1. Okay. The direction of acceleration is upward. Okay. And free body diagram for M2, we have tension 2 and weight 2. Okay. So the direction of acceleration is downward. Okay, second. Okay, for the second object, we have M1. Free body diagram for M1. We have normal force, weight, and tension. Okay, show the direction of acceleration. For M2, we have tension and weight. Show the direction of acceleration is downward. Okay, look at example. Okay, we have a system in figure below is in equilibrium and the surface are rough. Draw three separate free body diagram. Show all the forces that act on each block. So the solution. Okay, free body diagram for block 1, which is have weight and tension 1. For block 2, it have normal force, tension 2, tension 1, and weight and frictional force. And for block 3, we have normal force, we have weight, we have tension 2, and frictional force. 3. 4.2 Newton's law of motion. A. We have state Newton's law of motion. B. Apply Newton's law of motion. Newton's first law of motion state that if there is no net force acting on an object, if it is at rest, it will stay at rest. If it is moving, it keeps on moving at a constant velocity. Formula F net, or you can write summation of F is equal 0. Example, look at the ball. If the ball is at rest, it will stay or remain at rest unless acted on by unbalanced force. If the ball in motion, it will continue with constant speed and direction unless acted on by unbalanced force. Equilibrium of particle. is defined as the vector sum of all forces acting on particle must be zero. The equilibrium of a particle ensures the body in translational equilibrium, and its condition is given by summation of F is equal F net is equal 0. This is Newton's first law of motion. Right. This is equivalent to be three independent scalar equations along the direction of the coordinate axis. Summation F in component X is equal 0, and summation F in component Y is equal 0. Okay, type of equilibrium of particle we have 1. Static equilibrium mean velocity is 0. Body remain at rest or stationary. Second, dynamic equilibrium mean acceleration is equal 0. Body moving at a uniform velocity. Okay, Newton's second law of motion. The rate of change of momentum of an object is directly proportional to the net force acting on it. F is directly proportional to the rate change of momentum. According to this law, okay, summation of F is equal dP over dt. P is momentum. Momentum is a product of mass and velocity. So we got summation of F is equal V dm over dt plus m dv over dt. Okay, if the mass is constant, Newton's second law become summation of F is equal ma. Force is directly proportional to acceleration. The greater of net force acting, the greater the acceleration of the object. The acceleration is in the same direction as the net force. Okay, last one is Newton's third law of motion. For every action, there is a reaction of equal magnitude but acts in opposite direction. For example, when the student pushes the wall, it will push back with the same force. Then FAB is equal negative FBA, where FAB is a force by the hand on the wall. It's called as an action force. And FBA is a force by the wall on the hand. It's called reaction force. Action and reaction must act on different bodies during an interaction. They do not cancel out. Example, okay, a rocket moves upward as a result of a push exerted on it by the exhaust gas which a rocket has pushed out. Engine push a hot gas down as an action force, and exhaust gas push rocket up is called an reaction force. Okay, another example, work on floor. When pushing down on the floor with certain amount of force as an action, in response to it, the floor push back up onto you with the same amount of force. Without this equilibrium of force, we would either float around or sink through the ground. Push down is called action force, and floor push up is called reaction force. Lesson 4, 4.2 Newton's law of motion. B. Apply Newton's law of motion. Okay, we look for example 1. Figure 4 shows a 15 kg load held in equilibrium by ropes P and Q fastened to the ceiling at the wall respectively. 1. Sketch a free body diagram at point O. 2. Calculate the tension of rope P and Q. Okay, so sketch a free body diagram at point O. Okay, we begin at one dot. So we have TQ to the right. We have TP at the angle 65 degree from horizontal, and we have weight. Okay, so this is answer for free body diagram at point O. Second, we need to calculate tension P and tension Q. Okay, from the free body diagram, for tension P, we need to resolve it to Y component. T in Y component is TP sine 65 degree, and for X component is equal negative TP cos 65 degree, and weight in component Y. Okay, since the system in equilibrium, submission of Fy is equal 0. So, TP sine 65 degree minus with mg is equal 0. Substitute the value, and we got the magnitude of TP is 162 newtons. Right, and then to find the TQ, the submission of Fx is equal 0. So equation for Fx is negative TP cos 65 degree plus TQ is equal 0. Substitute the value of TP into equation, and we got the magnitude of TQ is 68.5 newtons. Okay, next to example 2. A block of mass 2 kg is pushed along a horizontal surface with a force F is equal 3.2 Newton. The block experience an acceleration is equal 0.3 meter per second square. What is coefficient of friction between the block and the horizontal surface? Okay, look at the solution. Okay, we need to draw the forces acting on the object. So first, it have normal force. Second, weight. Okay, external force and frictional force. You also need to draw the direction of acceleration. Apply the net force equation. Summation of Fx equal ma. So force in component S, we have external force minus with frictional force is equal ma. Okay, the equation for frictional force F is equal mu n, and n normal force is a mg. Okay. So F minus mu mg is equal ma. Substitute the value and we got the coefficient of frictional force 0.133. Coefficient of friction is no unit. Okay, let example 3. An object P of mass 4 kg is placed on an inclined plane. It is attached to an object Q of mass 2 kg by a string through a frictionless pulley. When released from rest, a 9 Newton constant friction force acts on P. Calculate the acceleration of P. Okay. First step, you draw all the forces acting on the both object P and Q. So for object P, we have normal, we have weight, we have tension in the rope, we have frictional force. And for object Q, we have tension and weight. Okay. After that, you can sketch a free body diagram for block P. Okay, begin at one dot. It is normal, weight, tension, and frictional force. Okay, also need to draw the direction of acceleration. And for block Q, have tension and weight. And then we analysis from the free body diagram for block P. Okay, summation of Fx is equal ma. Okay. So what force act in component S? We have tension plus W sin 30 degree minus frictional force is equal MA. Okay. Substitute the value and we got T minus 4A equal negative 10.6. So you have two unknown here, T and acceleration. So this is for first equation. Then we analysis for free body diagram of block Q. Okay, the block Q move in vertical component, so submission of Fy is equal MA. So we have W minus T is equal MA. Substitute the value and we got T plus 2A equal 19.6. So this is for second equation. Okay, you can solve this problem by using mathematical process. Equation 2 minus with equation 1 and we got 6A equal 30.2. So A is equal 5.03 meter per second square. Okay. Example 4. Two blocks, A of mass 10 kg and B of mass 30 kg are side by side in contact with each other. They are pushed along a smooth floor under the action of a constant F of magnitude 200 Newton applied to A. Determine A, the acceleration of the blocks, B, the force exerted by A on B. Okay, look at for equation. Okay, draw all the forces acting in the block A and block B. So this system, block A and block B, move to the right. The system moves to the right by the applied force of 200 Newton. So we apply Newton's law of motion. So the total force is 200 Newton. Mass A 10 kg plus with mass B 30 kg times with acceleration. So acceleration we got is 5 meter per second square. Okay. Second. Okay, we need to draw a free body diagram for object B. And the question asks to you to find FAB. Apply Newton's law of motion. Submission of Fx is equal ma. So Fx is equal Fp is equal MBA. So substitute the value and we got FBA is equal 115 Newton. Okay. So from Newton's third law, FAB is equal FBA equal 115 Newton. Okay, that's all for chapter 4.